Hello everyone, I hope you all are doing great. So today we'll be looking into the review exercise number 1 of Sin Board, Sin textbook. It's the book of first year, and today we'll be solving the exercise number 1, which is MCQs based review exercise. So without any further ado, let's get started. First of all, in the first question, we are given a condition. Let me just reduce my pen's target. Here you could see they are saying that for any complex number z, the mod of z is equal to, what could be the condition? First of all, you must know that what does it mean by numbers, the feature z, and what does it mean by the mod of z. Z is an integer, z is an point on the graph which represent two of the cases. First one is a constant a plus second one is an imaginary number. For most of the condition, you'll be giving the two values. First one would be the normal real number, and second one would be the imaginary number. Combinedly, this is known as a complex number. Now, what does it mean by the mod of z? Whensoever you take an condition where you have to just keep under root, then you have to square a plus, then you need to square b of the imaginary part. So in this case, this feature is known as the mod of that complex number. Now in the question they are asking that what could be the possible answers, what we could say the possibilities of the answer of mod. Either it can be an conjugation. What does it mean by z and a slight line on top of it? It actually means when you change the sign of the imaginary part. If you are given a condition where a plus b imaginary part iota is the condition, so the conjugate of the z would be a minus b iota. Now further we do have question like that where we have to conjugate things out. So for now just keep this in mind, whensoever we change the sign of the imaginary part, this is known as the conjugation. I hope this thing is clear to you. So they're asking that could be and condition, there is any condition where we can take mode of n conjugated real number or n conjugated complex number. Yes, we can take the mod of conjugated complex number, because what is mod? Mod is just an an condition where we have to take under root of the given two values. So yes, it can be a situation if you are given a minus b iota. So we are not concerned with the symbol. Howsoever, if we'll put the symbol in the case, so again after being squared, it will become positive. So this can be a condition. Then in the second part it says minus of the z, that means that whole complex number is being multiplied by negative sign. So in this case, if we are given this general form, so in that case it will become minus a and minus b iota. Now again we are not concerned about the symbols here. We are concerned about only the values, and we are only concerned till the time we are not getting the mode. Again in the third option, this is also a possible thing. Again in the third option they are saying that if in a situation you are given first you need to take the square, then again you need to conjugate it, means you need to change the symbol of the imaginary part, so it will become minus a plus b iota. So again the same point, we are not concerned about the signs, so this is also the condition. So overall option number D is correct. I think my red pen is like of really great weightage. Let's just circle it down. Now let's move on. Okay, so now we do have second question, which actually says that if we are given a condition z1, that means an complex number, then we do have z2, which is another complex number. So what would be the possible conditions? What could be the possible values which we could consider, what possible conditions could we consider as the product or the or the subtraction or addition of both of the complex number. So this is a general thing that you need to understand, that whensoever we add two of the elements, two of the complex number is actually less than and equal to the mod of two of the complex number. This is a general thing. It would be great if I could actually show up in the starting, maybe it's in the 17th number. It's in general condition. Here you could see it's the line of the book, and it's the triangle inequality of complex number where the negative subtraction of mod z1 minus mod z2 is less than and equal to the product of two of the complex number than their mod, and it is again less than and equal to the mod of that z1 in addition with mod of z2. This actually concept explains us that whensoever just suppose that we are taking subtracting two of the mods, so that value would be the least value then as compared to adding up two of the complex number, the same two complex number, and then taking mod, and again it's less than the third value, like taking mod after first taking mod and then adding up. Well, so the this condition is true. This thing you need to understand, since there's a complete concept behind it, geometrical proof behind it. This is the general figure which makes us understand that why these three functions are being performed. Okay, the mod value, the graph of the mod is something like this, that I think you need to know, since there's a rapid change and then a rapid increase in the value. That's what usually mod do. Well, in this third equation, we are given a situation where z is equal to 3i minus 4, and then we have to find out z plus z conjugate. First thing, you need to arrange it. That's the first condition. Since the real part should be in the front, which is minus 4, and then we need to add in 3 iota, that is the imaginary part. Then they are saying you need to add the conjugated version of this thing. That means again we will be having a minus 4, but this time there would be a minus negative 3 iota. We need to change the sign of the imaginary part. So in this case, these two things would be cancelled out. Minus 4, minus 4, minus into minus would be plus, but negative 8 would be the answer. So let's see, is there any option like that? Yes, C option is correct. Then we do have fourth question. If A is greater than 0 and B is less than 0, so what conditions would be applicable? So first of all, keep this in mind. Whensoever a negative number, that means A is a number which is, this is a 0, A somehow exists here, minus 2 minus, and somehow it exists here, and B exists here. So whensoever we'll take product of both, like if we'll take product of minus 2 multiplied by 2, just in case, so our answer would be minus 4. So the product of both of the conditions would be always less than 0. This is the concept. Okay, let's get back to the condition MCQs number 5, which says that if n is an even integer and iota is equal to, now there are few conditions that you need to understand. I would be always equal to under root minus 1, whilesoever I square could be equal to 1, no, minus 1. I cube would be equal to minus iota, and I power 4 will be equal to positive 1. here it will be again it depends upon the condition. Either you consider it under root minus 1, either you can consider it positive iota. So these four conditions you need to understand, and for its clarification, iota is again equal to iota, and we know if we'll square iota, that means we'll keep square at this end, so the under root will be cancelled out and we'll get minus 1. This is the condition where I have broken it down, I square dot iota. So I square is equal to minus 1, so it will be multiplied by iota, so it will become negative iota. Then I power 4 means I square into I square, that actually becomes equal to minus 1 multiplied by minus 1, so it's equal to positive 1. This is how I have just taken out these values. So here, if it's an even integer, so there is possibility it can be a positive 1, it can be a negative 1. So we'll consider the C option, which says that it can be a positive 1 or it can be a negative 1. Then move on to the sixth part, which says if z is any real number x, then its conjugate will be. Keep this in mind that real number isn't conjugated. Real number stays just like that. We actually conjugation is only for the imaginary part, not the real part. So if x is a real number, so it will stay x. So this was it for today. I hope that these starting 6 MCQs are clear to you. If you got any question, just DM me. I'll upload the second and third part solving out these questions in detail again. So this is sort of review of this this whole chapter as well. So yeah, thank you so much for joining. Bye bye.